Hello once again. In the previous video, we have seen how RAS is responsible and how hypothalamus is responsible to control the kidney or to regulate the kidney, to be very precise. Now in this section, we are also going to see one more component, that is atrial natriuretic factor. Now this is one more proteinaceous hormone which is capable to regulate kidney, but the most important thing about this is that this is opposite, it works opposite to RAS. Just like insulin and glucagon, even ANF and RAS works opposite to each other. It will not be incorrect to say that ANF, that is atrial natriuretic factor, is antagonistic, that means opposite, antagonistic to RAS. Now it is very much important to understand that ANF is stimulated, that means it gets activated only if the person has high blood pressure or high glomerular filtration pressure, GFP. If the person has high BP or experiencing high BP, or if it is he is experiencing glomerular filtration pressure like more than the normal level, the ANF gets activated or it gets released. Now opposite to it, RAS gets activated if the person has low blood pressure, if the blood pressure has been fallen, or if the person has low GFP, the RAS mechanism will get activated. So they work opposite to each other. Now let us understand what exactly ANF is. So as the name suggests, atria, that means something to do with heart. Yes, this is our heart, and these two chambers are atria. These upper two chambers are atria, and in this region ANF is synthesized. So atria releases ANF. This ANF will reach to the target tubules of nephron, and it will inhibit the effect of aldosterone. Now we know that aldosterone is responsible to reabsorb the sodium, salts and water. So that means ANF will allow the excess sodium and water, especially sodium, okay, to pass through urine. ANF will allow sodium to go out of urine. Thus by reducing, or thus by eliminating the sodium, it brings down the blood pressure. It brings down the blood pressure. and this is how it controls the condition of high blood pressure experienced by the person. We know that whenever the person has high sodium in blood capillary, the person has high BP. So to counteract the ANF, what does ANF do? The ANF first of all do not allow the sodium to reabsorb. Okay, the reabsorption will be inhibited, and instead these sodium will be excreted, okay, into the DCT. This is the job. This is the job of ANF. ANF causes this activity to happen. So let us summarize RAS and ANF together. Okay, condition of low BP or low amount of GFP or low amount of GFR will activate RAS. And what will RAS do? After activation, the RAS will try to bring up the blood pressure, GFP or GFR. Whereas if a person is experiencing high blood pressure or high glomerular filtration pressure or high GFR, the body will try to activate, or it will activate heart, that is activates atria. Activates atria and ANF is released. In turn, what ANF will do after activation? It will bring down the blood pressure, GFP or GFR. Okay, hope that is clear, and it's easy up till now. Now let us begin with another topic, that is micturation. So I hope this was clear, and we will move with micturation. What is micturation? Micturation is basically phenomena of urination. Okay, so the process of elimination of urine is referred as micturation. It's a simple process of eliminating urine, and this is basically under the control of again CNS. Okay, controlled by CNS, and to a certain extent ANS as well. We will try to understand. Basically the response is given by CNS, and the feedback is received by ANS. Somehow it is integrated. So step by step we will understand what is happening in micturation. It's basically a kind of reflex. So suppose this is a bladder. Let us consider this is a bladder, and as you know, the bladder will continue collecting the urine, and imagine that the urine is now filled inside the bladder, and bladder is thick wall structure. Urinary bladder is a thick wall structure which is comprised of three layers. The outer one is a protective connective sheet, the middle one is muscular, and the inner one is epithelial. Let us zoom this section of the wall, the one which I have circled with the green color. What do we find is the innermost layer, which is in direct contact with your urine, is basically a transitional epithelium. This one is transitional epithelium, and the second layer is made up of muscles, that is detrusor muscles. Now remember these muscles, just give me 1 second. Okay, what I was saying is detrusor muscles are involuntary in nature. Okay, they are smooth muscles and they are involuntary in nature, and they are innervated by nerve, especially parasympathetic nerve. I will come to it later. Just let us begin with the mechanism. Now what happens is, the first step is that urine formed or filled inside the bladder will exert the pressure on epithelium, transitional epithelium. In turn, will what happen? This pressure causes stretching of the bladder. Now, to a certain extent, the bladder will stretch, but after that limit, the stretch receptors are activated. The stretch receptors activates, and as soon as the stretch receptor activates, it sends signal to the brain. What does brain do? It sends two signals. The first one is sent to the dartos muscle, and it causes contraction. The response is contraction of that muscle. This will increase the pressure in bladder. The second response is that it leads to the relaxation of sphincter. So urethral sphincter gets relaxed, leading to the release of urine. And this release of urine is referred as micturation. Okay, so it's kind of neural reflex, and it is all the reason or the mechanism which causes micturation is referred as micturation reflex. I hope this is clear. There are certain points that we have to remember. That is, on an average, a person eliminates somewhere around 1 to 1.5 liters of urine. And what is the characteristic feature of urine? Basically, the urine has a pale yellow color, and that is due to presence of urea and certain other waste. There is this pigment called as urochrome, which is responsible for that color. Urea is actually not that yellow in color, but the main reason for the yellowish tinge is because of urochrome. And the pH of urine is somewhere around 6, which makes it acidic. So our urine is acidic, and that is the reason it shows pH 6, which is close to 7, but still it's an acidic one. Okay, hope you understood, and I will end for the day. Thank you.